and welcome to our conservation webinar from the Society for Conservation Biology. And we're very pleased to have you join us today. In just a few minutes, I'm going to be handing over to Jorge Menezes, who's going to give us a talk today. Just to say that the Society for Conservation Biology publishes 3 journals: Conservation Science and Practice, Conservation Biology, and Conservation Letters. And today we're going to have a presentation from Jorge, who has published a paper in Conservation Science and Practice. And we're going to have him present the results of a very interesting study. So I'm going to just wait for another minute or so, and then I'm going to hand over to Jorge. Okay. All right, we have another person coming into the waiting room now. Excellent.
Yeah.
So Jorge, are you ready?
Sure.
Okay. Excellent. Well, good morning, good afternoon, good evening, everyone. And thank you for joining our SCB Conservation webinar. Today, I've got the great pleasure of introducing Jorge Menezes, who is a behavioral ecologist with an interest in habitat selection and all diverse ways that animals use space. Jorge started his career at the Federal University of Rio de Janeiro, studying rodent behavior in fragmented landscapes. And he moved to study habitat selection under predation risk during his master's at the Federal University of Mato Grosso do Sul. During his PhD at Ben Gurion University in Israel, he worked on studying animal space use at the species level. And the study he's going to present today is one of these large-scale conservation studies, which he executed during his time as a consultant to the Ministry of Environment in Brazil and as a postdoc at Mato Grosso University. So without further ado, I'm going to hand over to Jorge, who's going to present today about deforestation, fires, and lack of governance, which are displacing thousands of jaguars in the Brazilian Amazon. Over to you, Jorge.
All right, thank you, Miriam. And well, this is one of the studies, like we commented, that I published recently with my friends and colleagues, Fernando Tortato, Luis Oliveira Santos, Fábio Roque, and Ronaldo Morato. And I think the way I would originally start a presentation is by introducing the topic, but I guess almost everybody is familiar with the with the topic of deforestation in the Amazon. It has been something that has been going on for a while. And I think no other place has shown that effect better than the state of Rondônia in Brazil. Just for the international viewers, the state of Rondônia is the one marked red in the map of Brazil to your right. And it's one of the 27 states that's part of this country. And here it's how it used to look like in 1984. Sorry, forgive me. And as you can see, it's already starting to have the first marks of deforestation. And this is how it looked like in 2019. So you can see that the process of deforestation is going and is going strong. However, the problem with deforestation in general is that although it clearly leaves a mark on the landscape, it's kind of a background process in the sense that most of the people are aware of its existence, but it's always happening slowly, and the consequences of it happen very slow. So we don't tend to think of it a lot. We don't tend to put it in proportion. And these used to be at least, let's say, the common sense that we had both in conservation science in Brazil and also among the public. But this feeling that this is a background problem essentially changed severely and rapidly in 2019, because we had an event in August 10th and August 11th that was known as the Day of Fire, which, as far as we are aware, is the first time that we had a large-scale web-coordinated arson in which a series of farmers from the region of the Amazon actually got together through WhatsApp and Facebook to coordinate 1,457 fires to basically coordinate all those fires to be made and to be done on that particular day. And this actually drew a lot of attention because the volume of fires actually created a gigantic cloud of smoke that through the time of about a month, it slowly moved towards the southeast region of the country. And in doing so, it basically covered the most densely populated regions of the country. And it was a quite marking cover since, for example, this is a picture that a citizen of São Paulo, the biggest city of Brazil with 40 million people, took at 3 p.m., 3 in the afternoon. And as you guys can see, it was basically night, like even with some of the buildings turn on their lights and the streets lights turning on. So it created a very strong impact in the mind of the Brazilians and and brought to the attention of most of the population what was going on in the Amazon, even though it was going on for a while. And of course, once it has such a spectacular effect, let's say, it attracted the attention of the media. And in doing so, people started looking for the reasons of why this Day of Fire was set up, why they chose this particular date, this particular year, what are the motivations of the farmers that did that. And for example, BBC managed to uncover from an anonymous source that this was essentially a politically motivated act. It was a way for the farmers of the region to show support to the President Bolsonaro, who had been elected on the year of 2019, and to show support for the president's developmental agenda. Bolsonaro was always in favor of developing the Amazon. And by developed, he means, you know, expanding the amount of farmlands and mines and essentially whatever would actually bring economical benefit. And the farmers were trying to do a sort of show of support, and also hoping that they would also receive support from the government if they show willingness, if they showed proof of work, essentially. And this was quite shocking also to the conservation community on Brazil, like it, and also even to the citizens. And then we immediately were interested in figuring out what is the size of this impact, not only of the Day of Fire itself, but of the continuation of this firing, of this deforestation process and this enhancement of the deforestation process in 2019. And when we looked at the data of deforestation by itself, the results were kind of mixed because but before talking to them, I just would like to give you the background of where this data is coming from. Mostly the National Institute for Space Research in Brazil, they set up a program, let's say, called PRODIGE, in which they use satellite imagery to every year estimate the amount of deforestation that has been going on in the Amazons. And they release those yearly estimates since 2004, when the program was created, and they continue up to today. And one of the things that we can see from this data is that if you look at the rightmost red arrow here on the corner, that after 2019, we had an uptick of deforestation. Like we went from 7,000 kilometers squared per year to 10,000. So we had an extra 3,000 kilometers squares of deforestation. And but in defense of, let's say, in the interest of fairness, this effect is not a sudden change of behavior. We actually had a trend of increasing deforestation since 2012. It's just that this trend seemed to have accelerated since in 2019. And this is, of course, these answers are a question of how grave is the situation, but it doesn't, it's difficult to relate in a sense, especially for the group of people that were in this study, which is people with natural interest in mammals and in more particularly in felids. It was not immediately clear what it means to lose this extra 3,000 kilometers, because how does it affect the actual population of animals on the Amazon, and how does it translate to actual numbers, to actually demography that in the end is what is relevant for conservation. And the problem is that it is not an easy calculation to do, essentially because density is not constant through space, right? There are areas that are, of course, have more animals or are more richer than others within the Amazon. So it's entirely possible that these 3,000 kilometers extra that have been deforested all come from badlands, and the impact of the deforestation will be minimal. But it's also equally possible that they are actually the richest areas of the Amazon, and then we lost a vast amount of species richness and a vast amount of individuals for every population. So we felt that we wanted something more out of this data. We wanted actually to know how many animals have been displaced. And what I mean by displaced here is, in a very general sense, the animals that have been affected, that they either had to move away, or they were killed, or in some way they have been removed from the location that they used to be. And another reason we started getting interested in the concept of displacement is because displacement is relatable to humans. We have seen like a series of refugee crises going on around the world, and it is essentially the same mechanism, like by an effort, by an external force, individuals are being displaced from their original locations and moved to other locations. And what makes it even more relatable is that the UN now has introduced the concept that because of climate change, we will have climate refugees, climate displacement. And it is very, at least clear to me, that these effects, the first ones to be affected by this climate displacement, by this process of climate refugee crisis, will be the animals themselves. So it is a process that will be intimately shared by both humans and animals as a consequence of our actions on the environment. So we're pretty interested in knowing how much animals are going to be displaced. But the problem is it's quite difficult to calculate that because we need an actual measure of density. And measuring density has all the difficulties that many people are aware, that you have to actually measure what is the effective sample area and stuff like that. But on a more broader scale, we also have the problem that we are usually interested in more susceptible species, which are either species that are large mammals or iconic animals that we can that can work as umbrella species, or we are interested in species that we know that are basically on the brink of extinction, that are close to being extinct. And both cases are species that are usually rare. They are, and so to get an accurate measure of density, one would have to do a lot of actual effort to get an accurate measure, since the numbers of the species are very rare. And also, since we're talking about Amazon, we also have to sample a relatively very large area. And in many of those cases, those areas are still remote and difficult to go through. So it is difficult to actually sample properly such a large area as the Amazons. And finally, for us to actually calculate displacement, we not only need information of density, but we also need precise information of where the fires are working. In some places, we do have this information, but in many others, we don't. And because of all those difficulties, as far as we are aware, there was only one measure of the number of displaced animals in the Amazons, and more specifically on jaguars, since jaguars is one of the species that we actually have more information about. It's one of the most studied species in the neotropics. So this estimate was that basically, because of these fires of 2019 in Bolivia and in Brazil, we have around 500 displaced jaguars. That estimate came from the Pantera non-governmental organization. But their calculation was relatively simple. They essentially just looked at the amount of fires that happen in both the countries and used a blanket density of 2.5 jaguars per 100 square kilometers for the entirety of the continents. And while this estimate is nice because it gives us a measure across multiple countries, it is not very precise, especially because density in this case is not varying through space. So we thought that maybe we can do a better job if we get a more accurate result if we actually reduce our scope. So we decided to focus on the Brazilian Amazon. And the reason we decided to focus on that is because, again, the National Institute for Space Research in Brazil has this sensor called DETER, which essentially is a sensor that actually draws the locations of every deforestation that they discover that has at least 6.25 hectares, which is a relatively small resolution for the scale of the Amazon. But most importantly, they have the results published every 5 days, which was particularly useful for our case because we were interested at the time in which we were doing the study. we were interested in the deforestation on that year, on the year that the study was being conducted, which is 2019. So the DTER is one of the few tools that we had to actually give live indication of deforestation. I mean, live in the sense of 5 days, but it still is much better than, for example, the PRODE sensor that I mentioned before, which was an yearly estimation. So by reducing the scope, by focus only on the Brazilian Amazon, we could have this almost live information of deforestation. And we were also aware of this study by, sorry if I butcher his name, my Polish is definitely not, is non-existent, by this study by Judrzyjewski, which basically estimated the jaguar density in the entire range of the species. They produced a raster file, essentially a grid file, with the densities for each cell, and the cells had 1 kilometer by 1 kilometer resolution. They did it so by basically combining studies, densities calculated by 117 camera traps, and they kind of interpolated the data based on the quality, on the probability of presence estimated by species distribution modeling. So essentially, they combined two tools here: the compilation of all those camera trap studies with a species distribution modeling to act as an interpolation device between the studies. The only problem with this data is that it used studies that are from 2015 and early, so it doesn't actually cover the same period as the DTER system covers, but we thought that would still be worth the effort, since it's basically the only data that we have with that quality. So with those two data sets, the jaguar density and the DTER system, we can basically calculate the number of displaced animals by basically doing a simple multiplication. We can take our map of jaguar density, which you can easily turn into a map of jaguar numbers, expected jaguar numbers, since we have an density and we know the area of each pixel. Excuse me. And we can use the processing GIS known as masking, which is essentially multiplying those areas by a map which has 1 for if the area is within a deforestation polygon, or 0 if the area is outside of a deforestation polygon. And then if we multiply these two maps, we get a map that represents basically the number of jaguars displaced in each cell. Summing across all the cells, we get the final number of displaced jaguars. And it's a very simple method, and the advantage is that it can be done with any area that you want. You can do it for the entire Amazon, you can do it for each state of Brazil, you can do it for each municipality of Brazil, or even for each polygon of deforestation. And basically, we decided that, well, since we have this ability to actually do it in different scales, we might use that to actually try to figure out what is causing the displacement in the jaguars, to actually kind of analyze and break down what are the effects that are influencing this displacement. We decided then to do the analysis by state. So in essence, we calculated the displacement for every state in all the 4 years, which gave us a total of 36 samples. And then we could actually use those 36 samples of displacement and try to correlate it with environmental and social variables that we thought might influence the deforestation itself, the displacement itself. So we decided to stick with the scale of state, because in that scale, we actually have the information on the efficiency of cattle production, which we thought would be one of the main determinants of deforestation. And so essentially, we did a linear model in which displacement was the response variable, and has the independent variables. We used first the proportion of of areas of the area of the state that is unprotected forest, which to calculate that, we basically use a map of forest cover that we downloaded from NASA, from the Terra satellite. We essentially use the rule of thumb that if a location had more than, a pixel had more than 50% of a forest cover, it would be considered a forest in itself. And then we use the world database of protected areas to mask out, to remove the areas that are protected itself. And then we counted the number of forest pixels that remained, which are basically unprotected forests, and divided by the total number of pixels of the state as a whole. And that gave us the proportion of the state that is composed of, that is composed of unprotected forests. Using the same map of forests, we calculated the average distance to a deforestation border, which essentially for every pixel of forest, we calculate the minimal distance to a non-forested pixel. And then we took the average for the entire state. And the efficiency from cattle production, an economist had recently done, not recently actually, in 2005, had done an estimate of the efficiency of cattle production in each of the states. And if I am recalling correctly, he essentially just calculated how much money each farm makes compared with the total cost of the inputs that the farm has. So essentially how much profit, a ratio of profits that each farm has, and he made an average, an estimation of an average for every state. And finally, we added state as a covariate just to account for the fact that some states just have higher density of jaguars, and as a consequence, they would naturally have a higher displacement of jaguars just because they have more jaguars. So moving on to the results, we found that essentially we have roughly 300 jaguars being displaced every year and throughout the entire Amazon. And we see that the majority of this displacement seems to be happening in two states, the states of Mato Grosso, which is the one, the southernmost one here on the map of Brazil, and the state above it, which is the state of Pará. And they seem to be consistently, essentially killing around 100 jaguars every year. And while they are the two of the biggest states, Amazon is equally big and has much lower numbers. But we also have, despite having those two negative examples, we also have two positive examples, which is the states of Maranhão and the states of Tocantins. And especially good is the state of Tocantins, which actually managed to zero out the deforestation, the displacement of jaguars. And Maranhão is just basically going in a tendency to go down continuously. And seeing all this picture, we also tried to see if any of our variables actually managed to explain the displacement. And we're not so lucky on that front because, and surprisingly, we found no effect of cattle efficiency. And this was quite surprising for us because we thought this would be one of the main determinants. First, because of theory, because there is now this idea that in conservation of land sparing, which is basically that if we had increased the efficiency in the production of your resource, there would be a greater opportunity for conservation because there would be a smaller consumption of land. And we also had this common belief in Brazil, at least, that the people who are executing the deforestation are usually not as educated and don't have another opportunity to find work, hence why they engage in such illegal deforestation and illegal cattle ranching. So we had this idea that if we had more efficient production systems, we would have less deforestation by itself. But this turned out not to be the case, or at least we don't have any evidence that this is the case. And one possibility to explain that was actually by a study by another researcher in the area, who basically argues that land sparing only works when there is already a limitation of land. If you just increase the efficiency, but it's equally easy for farmers or cattle ranchers to just acquire more land, they're just going to use the extra capital that they gain from their increased efficiency to acquire even more land and then make even more money. So this could be one of the explanations of why we didn't find the land sparing effect or the land support for the land sparing theory. And another explanation also comes from the thesis of the same economist that calculated the efficiency of cattle production. Essentially, he showed that usually in municipalities in which you have more education, you have a tendency of the rural landowners to move away from cattle production and into more profitable crops. So there is this tendency that cattle production is only engaged by those that don't know that it's actually a bad deal, that you can use the land in a more efficient manner and make more money through other crops. So perhaps the reason we don't see an effect as predicted by the land sparing is simply because there is never an efficient cattle production, because as soon as an individual acquires enough education or enough means to execute an efficient production of rural materials, he will immediately jump out of cattle ranching and move towards agriculture or other more efficient products, more profitable products. So this might be one of the explanations also. Simply everybody who is engaged in cattle ranching doesn't have an alternative to be efficient. And the only actual variable that we did find an effect was the amount of cover, essentially, the amount of unprotected forests in the state, in which if you have more unprotected forests, it means that you have less displacement, which we interpret as just being the fact that if you have more forests, it usually means that you have less deforestation. And if you have less deforestation, you have less displacement. So the result was not necessarily something surprising for us. So kind of a little bit bummed out by the fact that we couldn't find any quantitative evidence of what's causing the displacement. We start to take a look more or less on the policies and on what could have caused the good examples and the bad examples of our states in our results. So looking first at the good examples, we have Maranhão, the state that has been showing a continuous decrease in the number of jaguar displaced. But unfortunately, this might be a false good example, because this is a cut of the Amazon region within the Maranhão state. And as you can see on this map from Celentano, the majority of I'm not sure if you guys can see my mouse, but the majority of the forested area that remains in the state is either covered by indigenous land or by conservation units. So it's possible that we are seeing a relatively decrease in displacement simply because everything that was there to be the forest has already been deforested. So now the deforestation is limited to more daring attempts to get within indigenous land or conservation lands. And as a result, it's a process that is slowing down. And Tocantins, we couldn't find any evidence other than there seems to be a policy by the governor of the state to reduce legal deforestation permits. According to the agency of the state itself, they have become substantially more strict on their giving of legal deforestation permits, and as a result, less deforestation has been going on. On the negative side, we have this constant effect of Mato Grosso, effect in Mato Grosso, they're saying, in which you constantly have 100 individuals being killed, with a small decrease in 2018 of 88 individuals only. But according to this relatively old study of Fernside, much of the comes and goes of deforestation in Mato Grosso is caused by the price fluctuation in soybean in the international market. So it's very possible that this decrease in 2018 is just a reflection from the market of soybeans have a small crash and returning back to its usual terms in 2019. Of course, I don't actually have an evidence of that. This is just a speculation of mine, since the study actually stopped in 2005. And in Pará, which is another state that has had a very similar curve of displacement, we might be seeing just the fact that, according to the same study, there is a correlation between the deforestation in Mato Grosso and the deforestation of Pará, which happens essentially because every time there is a increase in price in the soybean in the international market, there is more deforestation in Mato Grosso, but there is also more buying land by the farmers from cattle ranchers in Mato Grosso. And the cattle ranchers themselves then mobilize their efforts to the state above, to the state of Pará, and restart their production of cattle on that state. So as a consequence, the soybean price also increases the production of cattle in the state of Pará. But the state of Pará, we found in another more recent study that could have stopped that negative trend, but unfortunately, they had some mismanagement of their own ecological funds, because the state decided to allocate a budget to municipalities that have higher deforestation rates. And the idea was that this money would be applied to reduce deforestation. The problem was that they actually gave the money, but they didn't implement any form of check on whether this money was being applied for ecological projects, or projects that would at least somehow reduce the deforestation. So in the end, the money was given, but there was no actual proof or test on whether it actually would have the effect that it was intended to have. So this shows that Pará has also this other level of difficulty on top. And although this jaguar displacement map showed us like how different states are behaving and how they are having success or failure on the concept of preserving jaguars, we believe that the map could have other functions that for future studies or for future management that would be quite interesting. And all of that stems mostly that we can calculate the jaguar displacement for every deforestation patch that we find. So one of the uses that we could have is to rank each deforestation patch based on their impact of jaguars, and assuming that the jaguars are a good umbrella species that represents most of the community of mammals and other species in the area, this could be used to kind of prioritize enforcement. Since we don't have at the moment, or at least as far as I'm aware, we don't have the ability to stop every deforestation attempt, we could at least use those maps of jaguar displacement to prioritize which of the deforestation patches we would fight against, we would send police officers to actually stop it. And another thing that can be done with this map is that since we can calculate the total number of jaguars in the Amazon, and the Brazilian Amazon, per se, and we can actually calculate the current rates, we can have an estimate of how long it will take for local extinction. Of course, this is a very crude estimate, and I'm not even included in the actual paper, but if we assumed the same rates that we're having now in 2019, we would have jaguars essentially until 2281. So it's quoting from this Chernobyl series is not great, but it's not terrible. At least we have 200 more years jaguars, which is a substantial time. So just to have a final take-home message, the jaguar displacement was reducing until 2019, the last year of our study. And in 2019, we had 100 more jaguars dying as a result of this extra 3,000 kilometers of deforestation that we have witnessed. And unfortunately, it doesn't seem that increasing the efficiency and increasing the ability of the farmers in the region to produce their resources better will decrease deforestation. So it seems that we are back to the old classical tools of fighting deforestation, which is just enforcing the existing rules and increasing the reserve systems, which, at least for the case of Maranhão, seem to be working. And that's it. I'd like to thank you guys for listening to me and for giving me the opportunity to be here. And also would like to thank the Ministry of Environment for supporting me during this time that I was working as a consultant there, and for the data providers, the National Institute of Space Research, and the Professor Gilles Drzyuski, who gave me who was very kind to provide me the raster files of jaguar density. That's it.
Thank you, Jorge, for your very interesting presentation. It's just a fascinating study and a very unique one, and we're very lucky that we were able to get you to publish in our journal.
Thank you.
Yeah, I wanted to open up to questions now. So for the participants here, do you have any questions for Jorge? And let's open up for question time right now. So one question I had, actually I've got a couple of questions for you, Jorge. Okay. The first is, in your paper, you mentioned that in a landscape where deforestation rates are really high, clear ownership of land could reduce benefit for clear cutters, for people who come in and illegally cut forest. So how is it possible that landowners can register their land officially? Is that a complicated process? And you know, how can that registration of land be promoted? And is it also possible that landowners who are official owners of land can be incentivized to protect forest habitat for jaguars?
As far as I'm aware, in Brazil, it is a complicated process to actually register your land. One of the difficulties that we have is exactly that, is even to pinpoint ownership, because we don't have a centralized system that actually aggregates who owns each land, right? We have a system that is basically based on having public notaries, and each one of them stores deeds for particular for particular ownership. So as a consequence, even if you are, let's say, interested in buying a particular piece of land, you would have to search first through many notaries who is the actual owner of that land. So, and since it's very difficult to buy land, it is very difficult also to show ownership of land that exists. And that creates a problem that is happening quite often and has been happening since since 1980s and so on, in that people would fake documents alleging ownership by doing this process of putting an actual fake deed inside of a drawer with crickets inside to make the paper look yellow, and then show that as evidence of very old proof of land ownership. And people would take that as legitimate because they don't have a central database to check that against. And that process makes it very easy to fake land ownership. So, and to have a process to incentivize proper use of land, I think one of the topics that I've been actually just thinking about is that if we found a way to actually pay the farmers to actually keep their legal reserves that they are forced to, because today we have this mechanism that I think is 30% of the land or 10%, I'm not sure about the percentage, but a relatively sizable amount of the land must be nature reserves. But for the actually owner of the land, this is a onus. It's not an actual benefit. And so it's very tempting for them to just break this rule from an economical point of view. So I guess if there was any form of restitution of giving money towards keeping that land or rewarding those who keep those lands, there would be actually an incentive to actually protect it.
Right. And so you also mentioned in your presentation that land sparing doesn't seem to be a model for conservation. Doesn't really work. So instead, is it possible to have land sharing and to have wildlife or jaguar-friendly farming by encouraging farmers not to clear additional land, to leave patches of forest that might be used as stepping stones for jaguars, to avoid hunting of jaguars and their prey species, and to somehow come up with some kind of reward system for farmers that maintain jaguar-friendly farming practices?
I think so, including almost by accident, by nature. The cattle ranching is something that is relatively positive for the jaguars. While they do need the forest and they need a sizable amount of forest, they actually tend to hunt the cattle in very large amounts when they have the opportunity. So the cattle in itself provides a sustainable a source of food for them. The only difficulty on the process is to actually reduce retaliation killing, because the farmers, the cattle ranchers obviously don't like to have their cattle being eaten by jaguars. So they tend to hunt back those jaguars. So perhaps a policy of actually repaying or even giving extra money for each cattle rancher, for each cow or bull that has been eaten, would actually maybe incentivize them to keep the jaguars, in a sense, because it would turn it, instead of being a nuisance, in a profit. So yes, perhaps land sharing, as long as we have a substantial amount of forest left, could actually be a good possibility.
Right, and one more thing that you mentioned at the end of your talk was about enforcement. And, you know, I just wanted to, you probably know this, but August the 10th in 2019 was the Day of Fire. And we are here today in August the 11th, 2 years later. So it's kind of iconic that we're speaking about jaguar conservation today. And you know, that you mentioned that there was this coordinated effort to light fires and to destroy forest. And when those kinds of events happen, surely that really just overwhelms any existing enforcement response, meaning it's really, really difficult to address that threat. And hopefully that doesn't happen too often in this landscape. But obviously a big challenge with fire management. And who is responsible? What agencies are responsible for the enforcement? And how is that organized in this landscape?
As far as I'm aware, it depends on where the fire happens, which is something that is also related to something I discussed on the paper, which is the curse of common competencies, when you have multiple agencies that are responsible for the same factor. But overall, each municipality is supposed to have their firefighter corps. But specifically for fires happening inside of reserves, then is the responsibility, as far as I'm aware, of the ICMBio, that institute that supported me. And they do have an effort of constantly, especially during the fire season, let's say, the period in which the cattle ranchers are more active, they have a tendency of hiring people in advance and have this system of firefighters ready to put out those fires. The issue, however, it feels is that it's more on the security aspect, that those firefighters can't go there and fight the fire while the person who is putting the fires is still there. So it's usually a problem more of like, we have to make sure that the people who are doing that act are evacuated before, so we can actually fight the fire. Because in many cases, those arsonists, the people who are actually setting those fires, they are doing it in a somewhat controlled manner. They don't want to simply spread the fire continuously. They want to set fire on a particular area to create a pasture. So they end up fighting the fire themselves once it reached its purpose, it cleaned the area that they were intended to clean. So the problem is less of having uncontrolled fires and more of having people desiring to create those pastures, let's say.
Okay, very interesting. Sounds like it's a really complex issue. Management in this system. One last question from me. What is the role of private nature reserves in this landscape? Is there a role, do you think, for organizations, local NGOs, or even larger NGOs to purchase land and set it aside for jaguar conservation in the landscape, or to set up a system where small parcels of land are purchased, which can serve as stepping stones that link larger patches of forest? Is that possible, Jorge, do you think?
I think so. I'm not fully familiar with the details of what these NGOs are doing. I know that they are buying land, and I think it's a very good idea as long as they implement some effort of, unfortunately, of enforcement, of security of those lands. Because one of the issues that we are having, and at least it comes up on the media very often, is that even on areas that are already set by the government to be reserves, or even on some cases in indigenous reserves, we have people setting fires and setting up cattle pastures within those areas. And in some cases, even on the case of the indigenous reserves, there is an actual almost warfare going on. The indigenous arms themselves and try to regain that land from the cattle ranchers and struggle with that process. So just buying the land and setting up a reserve wouldn't be sufficient, because it's very likely that some of those cattle ranchers will trample over that piece of paper and will just put their pastures there anyway. If there is some form of enforcement or security, or even something as basic as a employee looking and warding the land, then making sure that is whole, would be much more efficient than just buying the land in itself.
Okay, very interesting. Great. Do we have any other questions from the audience here? Any other questions for Jorge? All right. Well, thank you so much for joining us today for SDB Issues in Conservation. And this is a recording, and what we'll do is we'll make the recording available to you and all SCB members after we're finished here, so that you can share it with your colleagues. But we thank you very much for coming, and we hope that we will be able to attract you to give a talk at our ICCB in December. So please look for an invitation to ICCB. It'd be great to have a talk from you and your colleagues about jaguars and deforestation, or also your more recent research on mammals, small mammals, which I understand that you're doing now there in Israel.
All right, so thank you for the invite. I look forward for it.
Yeah, thanks very much again for your time, and we really appreciate the efforts that you've made. It was a wonderful talk, and we'll be happy to share it with our members.
Right, good to know. Thank you.
Okay, thanks, Jorge, and thank you everyone for joining our conservation webinar series. And just to note that our next webinar is going to be next week, the 18th of August. And we're going to have Molly Grace giving a talk about testing a global standard for quantifying species recovery and assessing conservation impact. She's going to be talking at on the 18th of August at 5 p.m. GMT. So please join us for that webinar. All right, thanks everyone for joining, and good day, good evening, good night, and we'll see you next time.
All right,
bye.